So this was Monday night's homework, answers to angle addition and bisector practice. So these were short homeworks. All week, your homeworks are short because we split them into two. So we have like angle addition part 1, angle addition part 2. Then we'll have special angle pairs part 1 and special angle pairs part 2. They're all really short, doable homeworks. All right, so I'm going to move on to the next one, which was last night's homework to be done after the assessment. Look how short it was. Short and simple. So hopefully you have your questions ready to go. Which ones I need to work from angle addition part 1 or angle addition part 2. This is what your quiz covers. It's angle addition and angle bisector. Okay, so we're going to look at angle addition and bisector part 1. There we go. We're looking at 7 and 9. Number 7. QR bisects PQS. So the first thing you would do here is you would add arcs to your picture, because that's the symbol we use for angles to show that two angles are congruent. Arcs. Okay. PQR is 2x squared, and RQS is 7x plus 15. I know why you asked about this one. It's because it's a quadratic, isn't it? You didn't need help with the angle stuff. You needed help with the algebra stuff. Okay. So let's set up an equation. We are not going to add them together. That's the biggest mistake students make. They put a plus sign between those two expressions, and really you have nothing to equal it to when you do that. They're equal, they're identical twins, they're congruent angles. So we set them equal. Then you bring everything to one side, because that's what we always do when we factor. You get your parentheses ready, 2x and x, because honestly that's our only choice when we have a quadratic with a leading coefficient, 2x and x. Okay, so we need things that multiply to get 15. So we go to the side. 5 and 3, 15 and 1. Now we get to double one of those. We get to double, and we need to make a 7 out of it. So let's play around with that. Okay, if I double 5, I get 10. Could I make a 7 out of a 10 and a 3? Ding, ding, ding. So the 5 is the one that gets doubled, and this is the pair that wins. If the 5 is the one that gets doubled, I need to put it in a spot where it's going to get multiplied by the 2 when we FOIL. So the 5 is going to go there, the 3 is going to go here. 5 and 3, those are our factors. Now we figure out the signs. We want it to be a negative 7. So we need the 10, whatever's going to turn into the 10, to be negative. So this needs to be negative because it's going to turn into 10, and this one can be positive. Then we set these equal to 0. X minus 5 equals 0. 2x plus 3 equals 0. That's always the last step when you factor. So x is, let's see, add 5 to both sides, 5, and subtract 3 and divide by 2. If you want to put negative 1.5, there's nothing wrong with that. I usually leave it in fraction form. It didn't say to find x. It said to find the measure of PQS. So you have to plug it in. What I would do is just plug it into one of them. You can pick either one. I would plug it into one of them, and I would just double it. Okay? So we would do 7 times 5 plus 15, and then I would double it times 2. 100. And then I would do 7 times negative 3 halves plus 15, and I would double it. There's a big difference there. So it's either an 100-degree angle or it's a 9-degree angle. Next up is number 9. This one is kind of an odd one, but I have a feeling you'll see that again. I can't remember. True or false? Any figure made up of 2 rays is an angle. And you could really interpret this different ways. This is just saying, can you make a figure with 2 rays and it not be an angle? So, I mean, technically I could have a figure. Here's ray A, B, and then here's ray, I don't know, C, D. And that's my figure, and I've got 2 rays, but I don't have any angles at all. So that one's kind of silly, but you're just trying to, anytime you can think of a way to make it false, then that makes the whole statement false. Okay, so number 12. A point in the plane that is not in the interior of the angle must be in the exterior. So let's talk about point B in my picture. Is point B inside my angle? No. Is point B outside my angle? No. It is on my angle. So this is saying if it's not inside, then it's outside. But we're saying no, it could be inside, it could be outside, or it could be on the angle. So it's false. They're both false. This is angle, addition, and bisector part 2. This is number 3. The bisector of an angle is sometimes in the exterior of an angle. So if I have an angle, if I'm going to bisect that angle, if I'm going to divide that angle into 2 congruent angles, then I can't do that by adding a ray out here. That's not going to divide ABC into 2 congruent angles. So this is false, because if I'm going to bisect, if I'm going to cut this angle in half into 2 congruent angles, it's going to have to fall inside, interior of the angle. Number 9 is a good one. Okay, let's first mark this information up here. APC is a right angle, so I'm going to put a nice large right angle marking. BPD is congruent to DPE. So I'm going to put an arc and an arc. So PD is an angle bisector. Okay, so on number 9 it says more information to add on to that. Angle 2 is equal to angle 3. The measures are equal. So instead of adding even more arcs to my picture and kind of confusing all of my arcs, instead of doing that, what I'm going to do is I'm going to call angle 2 X. I'm allowed to do that. I can call an angle X if I want to. If I call angle 2X, then what would I call angle 3? Well, they're congruent. They're equal. Very good, Aaliyah. It's also X. Okay, what could I name angle 4 then? If angle 4 is congruent to angle 2 and 3 put together, good. I could name angle 4 2X. Okay, now, we know that this angle is a 90-degree angle. Do you know what angle CPE is equal to? Well, if APC is 90, then the one right next to it, 180 minus 90 is 90. It also has to be 90. So this angle is 90 as well. So I can kind of do a segment addition statement. X plus 2X equals 90. Because this angle right here is a right angle. It's a 90-degree angle. So I'm kind of doing part plus part equals whole. So from there, you can totally do it. 3x equals 90. X is 30. Find the measure of angle 2. Oh, we're already done because I named angle 2 x. And so angle 2 and angle 3 are both 30, and angle 4 is 60. All right. Okay, so vertical angles. This is on your vocab sheet, but we haven't talked about it in class before. These are the opposite angles. Let's look at these words. They're the opposite angles formed when 2 lines intersect. So that's really important. You need to have 2 lines intersecting, kind of making like the letter X, probably almost every time, yeah, making the letter X. And they're the opposite angles formed. So angle 1 and angle 3 are vertical angles. Angle 2 and angle 4 are vertical angles. Angle 1 and angle 2 are not vertical angles. So they're the opposite angles formed when 2 lines intersect. So you need to know what it looks like, and now you know what it's called. So here's what vertical angles look like, and here's what vertical angles do not look like. Students often get these confused. Angle 1 and angle 2 are vertical angles. 2 lines are crossing. Now angle 3 and angle 4, that's not just 2 lines crossing. That's not the letter X. That's a sideways letter K, right? So make sure you don't get them mixed up. 1 and 2 are vertical angles. I could make the letter X. 3 and 4 are not vertical angles. That's the capital letter K. We're about to learn that. Yes, they do. You might not have patty paper, which is totally fine. But in our classes here, we are drawing 2 lines on our paper. Just go ahead and draw an X on your paper and label the angles. You might be able to get away with just using a scrap sheet of paper to see that this is true, but you might already know that it's true. I'll demonstrate it for you on the whiteboard. How about that? We want to find out what's true about vertical angles. So if you did have patty paper, I would have you trace one of the angles onto your patty paper, and then I would have you rotate that patty paper around and see what conjecture you can make about the measure of angle 1 and the measure of angle 3. And this is not a coincidence. This happens every time. But if I were to rotate this guy, and then I were to put it over here, rotate it a little bit better, you will see that angle 3 is the exact same measure as angle 1. And if I were to do that for angle 2 and angle 4, it would also remain true. If I take angle 2 and I rotate it and put it right at, wow, perfect. Angle 2 is the same measure as angle 4. So really, when 2 lines cross, we're going to find out if you know one of those angles, you really know all 4 angles. But what we wanted to know about this slide is that vertical angles are congruent. It's called the vertical angle theorem. Write it down. Yes. If 2 angles are vertical angles, then they are congruent. Notice that's a conditional statement. If, then, hypothesis and conclusion. It's called the vertical angle theorem. Write it down. If 2 angles are vertical, then they are congruent. So I could add an arc, and then I can't add an arc here. I would need to add a double arc. Kind of looks like a rose or something when you do all of that. 1 is congruent to 3, and 2 is congruent to 4 in this picture. Is the converse true? If 2 angles are congruent, then they are vertical angles? No. But that statement is true. If they're vertical, then they're congruent. But the converse is not always true. All right. Okay, let's take a look at this picture from your textbook. We don't use your textbook a whole lot, so I'm trying to use a few tiny pieces of it. Cross braces are things that help keep deck posts straight. Have you ever been on a deck before? Has anyone ever walked on a deck? Hopefully somewhere at some point you have. If not, that's okay. But it should have braces on it. Should have braces to help keep it sturdy. Find the measure of each angle. So let's find the measure of angle 6 first. So measure of angle 6, 146 degrees. Why? Vertical angle theorem. So when it says things like justify your answers, get ready, because on Monday we're going to do mini proofs. We're going to start kind of proving things, or maybe not proving things, but at least justifying things. So when we solve something, we need to know why we chose that. I chose the angle 6 is 146 because of the vertical angle theorem. Okay, good. So now you're saying that the measure of angle 5 is equal to 34. And we are about to learn this, but that is because of the linear pair theorem. And we haven't learned that yet. So this might have gone better later in the lesson. But that's okay. And then 5 is congruent to 7, so angle 7 is 34 by the vertical angle theorem. There's multiple ways to do that. All right, the next word from your vocab sheet that we're looking at a little bit closer is adjacent angles. You're not writing this in your notes because it's already on your vocab sheet. When you hear adjacent, I want you to think next door neighbors. Next door. Adjacent. Next door neighbors. So angle 1 and angle 2 are next door neighbors. They share a ray. They're so sweet to share that ray. They have what's called a common ray, a common side, right here. But they don't overlap at all. So they don't have any common interior points. So think of your backyard and your next door neighbor's backyard. You have separate backyards, but you share a fence, right? So these angles have separate interior points, but they share that ray. So adjacent just means next to. Adjacent means next to. This is old news, complementary angles. I just wanted you to see two different ways that we could put complementary angles. Two angles whose measure have a sum of 90. Let me tell you one thing students get mixed up about. This angle right here, angle number 1, is not a complementary angle. What's that called? What's angle 1 called? A right angle. So an angle by itself cannot be complementary by itself. Notice it says two angles. Okay? So two angles whose measures have a sum of 90. So it's a pair. Supplementary. Two angles who have a sum of 180. So let me tell you a quick way to kind of not get mixed up between complementary and supplementary. So we've got C for complementary and we've got S for supplementary. How to not get them confused is you can take the C for complementary and you can turn it into a 9. Whoa! And you can take the S from supplementary and you can turn it into an 8. Cool! So there's a quick trick to help you remember complementary versus supplementary because people get them mixed up. Kendra, complementary and supplementary can be adjacent. They can be adjacent, but then they can not be adjacent. So they don't have to be adjacent. That's why I showed you both pictures. Some other people, it helps them to remember just a phrase, it's right to give a compliment, right? Like, that's the right thing to do to give someone a compliment. It's right to give a compliment. So right is your 90 degrees and compliment is your complementary. Whatever floats your boat. All right. Let's do an example. Name the complement and supplement of each angle. So to find the complement of an angle, we would take 90 and we would subtract the angle that we're given, right? So 90 minus 15 is 75. 90 minus 40 is 50. To find the supplement of an angle, we would take 180 and we would subtract the angle that we're given. Thus the 165 and the 40. But what if you don't find the answer, Ralph? What if I give you an expression, not the actual angle, but a whole expression? You would do the same thing. You would do 90 minus the angle that you're given. 90 minus the angle that you're given. Good. So 90 minus 20, well, you really need to distribute the negative is what you really need to do. So that's 90 minus 20 plus x. Because a negative times a negative is a positive. So 90 minus 20 is 70, and then plus x. So on this one, you would do the same thing, 180 minus the angle that you're given. So it's 180 minus 20 plus x. So that was a tricky one, but now that you've seen it, now you know how to do it. You just take 90 and you just subtract whatever I throw at you. Okay? Let's keep going. Ooh, a linear pair. This is probably the most important word of the whole unit. You are going to see this word all year long. I'm going to say this phrase all year long. Now, this is already on your vocab sheet, so don't write this down. A pair of adjacent angles, so next door neighbors, formed when two lines intersect. So really, I could keep going if I wanted to when two lines intersect. They are the next door neighbors, not the opposite, the next ones when two lines intersect. So that's a linear pair. Now we need a theorem. We need a linear pair theorem now. Here's what you write in your notes. Yes, write this in your notes. So we have a vertical angle theorem and we have a linear pair theorem. If two angles form a linear pair, then they are supplementary. If two angles form a linear pair, then they are supplementary. Just like the vertical angle theorem, the original conditional is true, but the converse isn't true. If you were wondering, I know you were. So on Monday, I'll ask you to back up what you're doing, and you'll use theorems to back up what you're doing, and that's why you want to have these theorems in your notes. Okay, can I move on? Okay, I just want to make clear what a linear pair is and what a linear pair is not. So make sure a linear pair, it needs to be supplementary and adjacent. So kind of two things you would need to look for. Those other ones, they're just supplementary, but they're not a linear pair because they're not adjacent. So to be a true linear pair, they have to form a straight line. They have to together already have made a straight line. And see the word line? The word line is in linear, so that's a clue that they need to form a straight line. All right, here we go. Let's solve some problems. Woo! We've always been Team Tanton, yes. Oh, that'd be fun. Okay, given ABD is 3x plus 4 and DBC is 56. We're keeping the algebra simple, guys. Notice we're not having you solve quadratics or anything crazy like that. We save that for the homework. Can a bisector form a linear pair? You can bisect a straight line, and then you'd have 90 and 90, sure. Oh, Ton is already done? So here's what we would not do. Here's the mistake students make when they're rushing. They just set them equal. I don't know why they do that. They don't know what else to do with them, so they set them equal. That is obviously not what we do. We're doing more of the idea of part plus part equals whole. Some people just say, oh, well, I'll just take 180 and subtract 56, and I know this is 124, and they'll just set 3x plus 4 equal to 124. It's up to you which way your brain works. So what are we getting for our final answer? So x is 40, and ABD is 124. X is not an angle, so don't put a degree symbol on x, whereas ABD is an angle. Not that I'm going to be picky about that. Not that I'm going to be picky. Okay, I'll give you a minute to look at this before I work it. Here we go. Ready? GHJ is 2x, and JHI, the whole angle, is 3x. Find x and the measure of GHI. So that other ray in there is just kind of there to confuse you. You don't need it. This is the same problem. Part plus part equals whole. 5x equals 180. X is 36. And JHI is 108. 36 times 3. Cool. Moving on. The complement of an angle is 3 times as large as the angle. Find the measures of both angles. I'm going to give you a minute to think. If you don't know where to start on a problem like this, okay, you already solved it. Here's how I teach students to solve it, because I feel like this way works the best. When you see the word complement, I want you to draw two angles that are complementary and go ahead and put them adjacent to each other just because of this picture, okay? So complement. The first thing you should do is draw a right angle and split it up. Not in half, but just split it up. The complement of an angle, so I'm going to call the angle x. The complement is 3 times as large. So I'm going to call the complement 3x. So the angle is x and the complement is 3x. Once you've labeled your picture, you're done. The rest is easy. Part plus part equals whole. Now, what students will do wrong is they'll take 90 and they'll just divide it by 3. But it's not 90 divided by 3. It's 90 divided by 4. So that's the important part of that one, okay? So x is 22.5, and that would be the measure of the angle, and its complement would be 67.5. So find the measure of both angles, 22.5 and 67.5. Can an angle be a decimal? Absolutely. Try same problem, different numbers. The supplement of an angle is 11 times as large as the angle. Find the measure of both angles. Because of time, I'm going to just have to work it. Okay, I see the word supplement. I don't see the word complement. So you need to draw a different picture. The supplement, so you need to draw 180 degrees. 11 times. So I'm going to call this one x, and I'm going to call this one 11x. It's going to work the same way every time. Add them together. Part plus part equals the whole angle, which is 180 degrees. 12x equals 180. The angle is 15, good, and the supplement is 165. Good. 15, 165. Amazing, guys. Okay, last slide of the day, promise. True or false? Let's look at our picture. Angle 5 and angle 8 are congruent. True or false? By the vertical angle theorem, it is true. Good. True. Why? Vertical angle theorem. That. Okay. Angle 4 and angle 7 are a linear pair. True or false? To be a linear pair, you have to be adjacent and supplementary. Those are not even adjacent. They don't even fit the first thing. False. Definition of linear pair. Okay, angle 1 and angle 3 are complementary. True or false? Number 3, true or false? Also false. Those angles do not add up to 90. And we're not even assuming. We know they don't add up to 90. Excuse me. Angle 1 and angle 4 are vertical angles. True. Angle 1 and angle 4 are opposite angles when two lines intersect. They make an X. Good. Angle 5 and angle 7 are supplementary. What do you think about that last one? 5 and 7 are supplementary. Uh-oh. Angle 5 and angle 7. They form a straight line. You're allowed to assume lines are straight. A straight line has 180 degrees, so turn your head sideways. Yes, they add up to 180. Absolutely, positively. Yes, 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 they're supplementary. They're a linear pair. They're adjacent and supplementary.